All right, welcome to section 10.2. Today we're going to be talking about arc length in terms of radians, and then also about sector area. So there's three different examples that we're going to look at and three new formulas as well. You can find some additional examples in your workbook on pages 282 to 283. Now yesterday we learned about what an arc length was, and we kind of came up with the formula for when it's in degrees. So now we're going to talk about how to find the arc length when it's in radians. Now remember, as we discussed yesterday, radian measures is a little bit easier to compute with than is degrees, and today we're going to see another reason why we like radians more as we get further up in math, why we're introduced to this particular different way of measuring angles. So first, recall that the arc length, when we're finding it in degrees, is equal to theta, the angle, times 2 pi r, but remember the 2 cancels out, and then over 180. So that's what the formula is when it's in degrees. This is how I find the arc length when it's in degrees. And now I need to multiply it by its conversion factor. And that conversion factor, remember, is either going to be pi over 180 or 180 over pi, so that I can get it into radians. Well, I already have the pi in the numerator, so that means that the pi needs to go in the denominator, and 180 will go in the numerator. Now something really nice happens when I do that, and not only do the pi's end up canceling out, but so do the 180s. And so I'm just left with my angle multiplied by my radius. So I just have to multiply those two things, and I know what my arc length is. So in other words, arc length is equal to theta times the radius. So that's our first formula for today that we've kind of derived to help us in solving them. So the first part of your assignment today is going to ask you to find the arc length and write your answer to the nearest thousandth. We're actually going to talk about it in terms of exact measure, and then also we'll find the thousandths. We have to draw a representation, and the angle is 5 pi thirds. Well, maybe you don't know exactly where that is. I know here's pi, and pi thirds is going to be more than pi because it's a number greater than 1. So it's going to be over in here somewhere. What we can do is just go ahead and convert it. I have 5 thirds pi, and I'm going to times it by, convert it to its degrees. So I'm going to times by 180 over pi. So the pi's will cross off, and 3 will go into 180/60. So this is actually 300 degrees. So 300 degrees, well, the whole rotation is 360, so 300 is about right here. So we'll say here's my rotation. And this is 5 thirds pi. And then my radius is 3 centimeters. So we draw a representation similar to what we did yesterday. Now, if you have not done so already, please make sure that you go and get your radian measures done on your unit circle. There's some great patterns that occur there, but I can see that pi, 5 thirds pi, is indeed 300 degrees. It kind of goes like this. For just a minute, we'll talk the pattern. This is 1/6 pi. Skip your 45. This is 2/6, which is pi thirds. This is 3/6, which is pi halves. This is 4/6, which is 2/3. Skip your 45. This is 5/6, 6/6, which is just pi. Then here's my 7/6, 8/6, which simplifies to 4/3, 9/6, which simplifies to 3/2, 10/6, which simplifies to 5/3. Skip your 45, 11/6, and then 12/6, which goes to 2 pi. And then for your pi, for your 45s, 45 is 1/4 pi. Then there's your 1/2, 3/4, 4/4, 5/4, 6/4, which is 3/2, 7/4, and then you're to 8/4, which is 2 pi. So kind of some cool patterns, but please make sure you get those in there. Once you kind of start to see those patterns, you shouldn't have to as often do the conversion. All right, so let's go find our arc length. So we know our arc length is I just take my angle, which is 5 thirds pi, and then I just multiply it by its radius, which is 3. Well, the denominator of 3 and the numerator of 3 can cancel out, or I could multiply them first and then simplify, and so I have an answer of 5 pi centimeters. This would be considered its exact answer. Its approximation would just require me to take and do 5 times pi, so 5 pi, and I would get 15 And remember, we're going to the nearest thousandth, so 15.708, and it would be centimeters as well. And this is considered the approximate answer. All right, so there's an example of the first type. Let's try one more. Again, you can pause the video if you want and then come back and see if you have the same answer. If I don't know what 2/3 pi is as a degree, I can times it by 180 over pi. Pi's will cross out, 3 will go into 180, 60, and 2 times 60 is 120 degrees. So here's 180, so 120 is about right here. We'll call that 2/3 pi with a radius of 12 meters. So then to find my arc length, it's my angle, 2/3 pi, multiplied by my radius of 12. Well, 3 will go into 12 4 times, and 4 times 2 makes 8 pi. So 8 pi meters is my exact. And if I take my calculator and do 8 pi, my approximate is 25.133 meters. Okay, so that's the first part of your assignment. You're going to use the formula that arc length is equal to theta times the radius when it's in radians. Now we're going to move on to our next formula, and that's to find the sector area. So yesterday and today so far, we've just been finding this length, how long this piece is. Now, given the angle, I want to know what that whole area, or what this shaded area is. So we're going to kind of derive it the same way that we did yesterday and looking at a part of a whole. So I have this part of the area, so we're going to call that the area of the sector. That's the part over the whole area of circle. And that's going to equal to a part, so the measure of the angle, so this part, to the measure of the whole. Okay, so that's in words. So let's go through and just kind of put in what we do know. So area of the sector, that's what we're trying to find. So I'm just going to call that big A. The whole area of the circle, we'll define the area of the circle. Remember, that's pi r squared. The measure of the angle, that's my theta. And the measure of the whole circle, what's the measure of the whole circle all the way around? Well, that's 360 degrees. So then what they say to do is that then you're just going to cross multiply just like we did yesterday to help us in finding the arc length. So I'm just going to do it over here to the side. I'd have 360A is equal to, and then I'm going to cross multiply this way. So I have my theta multiplied by pi r squared. And remember, I'm just trying to find out what A is. So I'm going to divide by 360. And so A will be equal to theta pi r squared over 360, because nothing will cancel out. Now remember, as we discussed yesterday, when I'm finding a part of a piece of the circle, it's the part of the area. So here's the piece of it. This is my angle out of 360, multiplied, because of means multiply, by the area, because sector area means I'm going to find the area, and it's a piece of the area. So in degrees, we would say that area equals my angle. There's of the part. So here's my part of the area. Now let's go find it what it's going to be in radians. So just like we did previously at the beginning of our notes, now we're going to go find out what it is in radians. So I need to again multiply by my conversion factor. And once again, I have pi in the numerator, so I'm going to put pi in the denominator and my 180. And this, just like when we were finding the arc length for radians, things are going to cross out. The pi's are going to cross out. And 180 and 360, 180 can go into both of them, so this will change to a 1, and this will change to a 2. So I'll still have my theta. I'll still have r squared. So remember, when it's arc length, it's theta times r, but now we're finding area, so there has to be a squared involved there. So there's my r squared, and then I'm going to divide it by 2. Or in other words, area is equal to 1/2 theta r squared. And again, if we have area, we've got to have a term that's being squared. And those are my formulas for sector area. And again, you're going to need to have these memorized. It's really helpful if you just think how we created them, and then you don't have to necessarily memorize them. You can just go ahead and say, oh, remember it's a part of the area to find sector area, and then just go ahead and convert it into radians for when you have to do radians. Okay, so we've got our formulas, so now let's use them. So the second part of your assignment today is going to ask you to find the area of the sector using degrees. So let's see if we can create that equation without turning our paper over. So area is pi r squared, and I'm finding a part of it. So here's my part of my area. So in the first one, area is equal to, my angle is 135 degrees, multiplied by pi, multiplied by the radius, which is 5 squared, so I'm just going to do that in my head, 25, and then remember it's out of the 360. And then it's just a matter of punching it into your calculator. So I've got 135, I've got my pi, I've got my 25, and then I'll divide it by 360. Rounding it to the nearest hundredth, or thousandth, excuse me, I'll have 29.452. And because we're talking area, my unit's going to be, because I have 5 centimeters times 5 centimeters makes centimeters squared. So now let's try B. So on B, my radius is 10 and my angle is 10 meters and my angle is 120 degrees. So area is my angle 120, pi, my radius is 10, so 10 squared. Don't forget to square it or you'll get every single problem wrong. Divide by 360. So again, I'm going to take my calculator, just do that calculation. So 120, my pi, my 100, and then divide by 360. So area will be equal to 104.720, and then it will be meters squared. Okay, so that will be the second part of your assignment where you're just going to simply find the sector area using degrees. The last part of your assignment and our last example is going to have a couple of pieces. It's going to ask us to change the degrees to radians. So notice how they give us degrees. We're going to have to get it into radians. Then we're going to find the area using the radian measure, and then we're going to leave it in terms of pi. So in other words, we're going to do the exact answer. So let's think about this formula. Well, it's area. Because it's in pi, or in radians, excuse me, we know that we're going to have our angle and our radius being multiplied together. And it's going to have to be squared. And then remember, we're going to take half of it. Because the 180 and the 360, when we do the conversion up here, the 360 and times by that 180 over pi will cancel each other out. All right, so first I have 60 degrees. Now maybe some of you have started to get those memorized. If not, 60 degrees, we have to times it by its conversion factor, which I need the pi in the top and 180, which would give me 60 over 180, so the zeros will cross off, and 6/18 is pi thirds, or you could say 1/3 pi. So my area, now let's just plug it in, is equal to 1/2. Then I need my angle. Well, my angle from 60 degrees is now pi thirds, so I'll put pi thirds, or you can put 1/3 pi, and then multiply by my radius squared. My radius is 4, so I'm going to again multiply that by 4 and square it, and 4 times 4 is 16. You'll notice as I was doing them, I was keeping them all as fractions. I find it helpful to just kind of keep them all as fractions and then cross cancel. I don't use my calculator on this section because I'm going to leave it in terms of pi. I need it to be exact, so I don't need to use the pi button. So I notice I can either multiply numerator and then multiply my denominator, but I notice that 2 will go into 16/8. And so in the numerator, I'll have 1 times pi times 8, which is 8 pi. And the denominator, the 2 canceled out and made it a 1, times 3 times 1 is 3. So that's my exact answer, is 8/3 pi, and then it would be inches squared. Now, if you want to use your calculator, I'm just going to show you how it's not all that really nice when you use the calculator. You could go ahead and do 1/2 and then times by 1/3 and then times by 16. But what's going to happen is your calculator is set to put it in mixed number. If it's an improper fraction, it makes it a mixed number. And we do not have mixed numbers for answers. We need to leave them as an improper fraction. So then you'd have to reuse the fraction button, press second and the fraction button again for it to give you your 8/3 pi. To me, that takes an awful lot longer to punch it in, so I usually don't do that. Okay, try B if you would please. And then if you want to pause the video and then come back. So I'm going ahead and converting my 120 degrees into radians. I would get 12/18, and 12/18 will simplify to 2/3 pi. So 120 degrees is 2/3 pi. So again, for my formula, it's 1/2, 2/3 pi, and then the radius is 2, so 2 squared is 4 over 1. Again, I can cancel. Well, 2 right here will go into 4, or 2 could go into 2, either one. Have 1 times 2 times pi times 2 is 4 pi. In the denominator, I have my 3, and it is in feet, and we're finding area, so it's feet squared. So 4/3 feet squared. And that is my answer using radians. Now, one last thing, you could always check your answer to see if your exact answer would be the same as your approximate. And I'm just going to do this really quickly. I could check using degrees. So I've got 60 degrees, so I can say area equals 60 times pi times my radius, which was 16, all over 360, right? So I could take my calculator and do 60 pi 16 divided by 360, and that would give me 8.378. And now if I go calculate what this really is, this is the exact answer, but if I do 8 pi divided by 3, you'll notice I get the exact same answer, 8.37 when I round 8. So these check. These are the same. This is the approximate answer, and this is the exact answer. So if you're taking a test or a quiz and you want to see if you've done it correctly, you could always check to see if your approximate matches your exact. All right, those are the 3 things you're going to see on your assignment today, where you'll find arc length using the first formula, and then you'll use find sector area using degrees first, and then using radians. Good luck and enjoy.